Alrighty, here is your key to the summer assignments. So this first set says, determine if the following relations are functions, explain why or why not. Okay, so first we have to know what makes a function, and we know that for a function, for every x, there is exactly one y. When you look at it from the equation standpoint, from the graph standpoint, you can look at it as a vertical line test if it's going to hit it more than one time. So if you know what your parent functions look like, and you know what the graph is basically going to give you, the y equals plus or minus the square root of x, your square root curve looks like this. It's your positive square root of x. So your negative square root of x is going to look like this. Right? So that does not pass your vertical line test. There, bam. So this would be a no.
May I have your attention, please?
This also does not pass the vertical line test. Remember, the whole point of the vertical line test is that shows you for this x value, there is more than one y value, which makes it a big no-no. Okay. So same thing here on number 2. You've got these 4 x values, but these 2 repeat. So this same x value has 2 different y values, so this one is a no also. Y equals 5 minus x squared. So for this one, you can look at it as a chart table of values if you wanted to, but if we go and graph this real quickly, we know that it gets shifted up 5, and then it's a negative x squared, so it sounds something like this. So it's your parabola, so this one is actually going to be a yes. So your reasons, these 3 have the same reason. That would be for each x, there is, oops, oh goodness, more than one y. And then for this one, for this yes, it's going to be for each x, there is exactly one y. That exactly is important. All right, so to simplify these expressions, start off over here. Got x to the 4th. I'm just going to rewrite him. So negative 2x cubed means I'm going to take the negative 2 and cube it, so that gives me a negative 8x cubed. Then 6 to the negative 2 power is going to give me 1 over 6 squared, so that's 1 over 36. X to the 0 power, anything to the 0 power is just 1. So then when I simplify this, I've got x to the 4th and x cubed. Those are being multiplied together. It's going to give me x to the 7th. It's going to give me a negative 8 in the numerator and a 36 in the denominator. So each one of those I can divide by 4. So that's going to give me a negative 2x to the 7th divided by 9. So over here, got 9x squared times 27 to the 2/3, x cubed. Okay, so I'm going to start by rewriting the 9x squared. I'm going to come over here, and we're going to look at this 27 to the 2/3 power, because there's 2 different ways to look at this. This is 27 to the 2/3 power. So since I have a 1/3 here, basically, if I can get this as a smaller base, something to the 3rd power, that would be helpful. So I could write this as, instead of 27, 3 to the 3rd power to the 2/3 power. And then when I put that over 1, and it's a power to a power, that's just going to give me 3 squared, which is 9. The other way to look at it is the cube root of 27 squared. It's pretty much the same thing. It's just a different way of breaking the base, I guess. So the cube root of 27 is 3, and then 3 squared is 9. So when I bring that back over here, I've got 27 to the 2/3 power. That ends up giving me 9. And then that's x cubed. So 9 times 9 is 81. X to the 5th power. Alrighty. So here, let's look at what's going on. So I'm going to take the 4 over 18, and I'm going to reduce that to 2 over 9. X cubed over x cubed, those cancel each other out. And then y to the negative 2 power over y to the negative 3 power. That's going to leave me with a y to the negative 1 in the denominator here, which means that's really a y in the numerator. So it look like this. And I wasn't sure where I was starting from here, so that's why that's so long. That's okay when that happens. I can leave it as 2y over 9 or 2/9 y. Alright, so here on this one, I've got to factor. So this is the difference of 2 cubes here. And so my difference of 2 cubes, cube root of 8 is 2, so that makes this x minus 2 times x squared plus 2x plus 4 all over that x minus 2. So then these two cancel out, and I am left with x squared plus 2x plus 4. Factoring is important. All right. So here I'm going to change this to multiplication. So this is going to become 5x to the 5th over 8 times 12 over 15x squared. So then when I go to cancel things out, this is going to give me the x to the 5th over x squared. It's going to make that x to the 3rd. The 5 and the 15, it's become 1, 3, 8 and 12. So 4 goes into 8 twice, goes into 12 3 times, and then this 3, these two 3's cancel out. So this whole thing over here is kind of just gone, and what I am left with then is x cubed over 2. All right. So then here I've got to get my common denominator. My common denominator is going to be a times b plus 1, which means this numerator here, I'm going to need to multiply this by a over a. So it's going to become a squared over a times b plus 1. Plus, I've got to multiply this by b plus 1 over b plus 1. So that's going to be plus b plus 1 squared over a times b plus 1. I guess I could have gone ahead and added those and just had one big fraction at this point. But so then I've got to multiply this out. This is going to give me a squared plus b squared plus 2b plus 1 all over a times b plus a. That is page 1. Page 2. All right, so what I need to do here first is I need to factor these. So this x squared plus 2x minus 3, when I factor that, this is going to give me x and x. I know one of them is positive and one of them is negative. And since that's a negative 3 and a positive 2 right here, then that's going to give me 3 and 1. And then here, when I factor out the GCF on this one, that is x. So this is going to be times, and this is going to be x times x plus 2. And then the denominator, which is this x plus 2. This right here gets factored. That's a difference of 2 squares. So that's going to be x minus 1. X plus 1. So then when I go in here to cancel, this x minus 1 cancels with that. The x plus 2 cancels with this one. And then that leaves me with x. So in the numerator, x times x plus 3 over x plus 1, or x squared plus 3x over x plus 1. There you go. All right, so I'm going to multiply in number 12. I'm going to start by multiplying this whole thing times the value of 1, which is going to be y over y. And when I do that, I've got to make sure that I distribute. And then that's going to give me, so y times 1 is y, plus y times 1 over y is just 1, over y times 1 is y, and then y times negative 1 over y gives me negative 1, and I can't do anything else with that. Can't cancel the y's out. Please don't be trying to do weird stuff like that. Okay, so here I've got to simplify my square roots. Well, I know that this is 7 times 100, so this is going to be 3 times 10 times the square root of 7, because that's how I would simplify 700, 10 times the square root of 7, plus 2 times the square root of 7. So this is going to give me 3 times 10 is 30, plus 2 will give me 32 square root of 7. All right, then 2 square root of 3 to the 4th power. I've got to take 2 to the 4th power and the square root of 3 to the 4th power. 2 to the 4th power is 16. Then the square root of 3 to the 4th power. So the square root of 3 squared is just 3, and then 3 squared is 9. So I end up with 16 times 9, which is 144. All right, so now we're going to solve. First thing I need to do here is distribute. So this is going to give me negative 10x plus 5 equals 3x plus 12. So then when I move this over here, I'm going to get 13x equals negative 7, which means x equals negative 7 over 13. Do not even attempt to give me a decimal there. All right, so here on 16, when I am trying to solve this, I am going to square both sides, get rid of my square root. So this is going to give me 15 minus 2x equals x squared. That means I've got a quadratic here, so I set it equal to 0. So 0 is equal to x squared plus 2x minus 15. So when I factor this, I'm going to get x plus 5 times x minus 3. So minus 3. Oh, goodness. There you go. Minus 3. So that means that my solutions, 3 and negative 5. Okay, so now we have to think, do both of those answers make sense? And when you have this square root, this is the principal root. We squared both sides to figure out what our answer was, and by doing that, we introduced some solutions that may work here, that may not work here. So the answer that you would get just from this would be a positive answer. So that means that we do not want this one. This is extraneous. And our solution is actually just 3. Okay. All right, so number 17. Now 2x squared plus 3x equals 6 minus 2x. So again, I have a quadratic, so I'm going to set it equal to 0. So 2x squared plus 5x minus 6 equals 0. When you try and factor this one, something like this, it's not going to work. Can't factor it. So you're going to have to use, well, you don't have to, but the way to do this is with the quadratic formula. So we know that x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a, oops, which is not 4, it is 2. That's a 2. So this is going to give me negative 5 plus or minus the square root of 25. And then 4 times 2 is 8, times 6 is 48, and that's negative and negative, which makes it positive, so it's plus 48, all over 4. So 25 and 48 is going to give me, oh, I'm totally going off into that one, negative 5 plus or minus the square root of 73 over 4. Can't simplify that anymore, and so there's my answer. Alrighty. So now, x minus 5 squared equals 9. I can take the square root of both sides. So this is going to give me x minus 5 equals plus or minus the square root of 9. So that means that x minus 5 is equal to plus or minus 3, because you can get either one is going to give you that 9. So this is going to give me x minus 5 equals 3, and x minus 5 equals a negative 3. So this is going to give me 8 and 2. All right. I don't know how much room I have for this here, but I'm going to FOIL these. So x plus 7 times x minus 1 is going to give me x squared. Then we get plus 7x minus x, so this is going to give me plus 6x minus 7 equals x squared plus 2x plus 1. So when I go in there to start subtracting, when I subtract x squared from both sides, those go away. And then I can move my 2x over here, so I'm going to get 4x equals 8, which means x equals 2. So absolute value. Since the absolute value of 1 minus 4x equals 5, then that means that 1 minus 4x could equal 5, or 1 minus 4x could equal negative 5. So then this is going to give me negative 4x equals 4. So negative 1 equals x. And then negative 4x equals negative 6. So x equals 3/2. And then my set is negative 1, 3/2. All right. 21. 21, there we go. I am going to, oh shoot. I'd like to clear my fractions, so I'm going to multiply, if I multiply through by 3, that gets rid of this one, multiply through by 7, that gets rid of this one, so 3 times 7, I'm just going to go ahead and multiply everything times 21. Okay, so 21 times x plus 1, the 3's will cancel out, so I'm really just multiplying that times 7, so 7 times x plus 1, plus 21 times this, the 7's cancel out, so it's really just 3 times x plus 2 equals, and then 5 times 21 is 105. So when I simplify this, I'm going to get 7x plus 7 equals 3x, oh not equals, I'm sorry, plus 3x plus 6 equals 105. This is going to give me 10x plus 13 equals 105. So 10x equals 92. So x equals 92 over 10, which is going to give me 46 over 5. All right, log base 3 of 243 is going to give me, that means that this becomes 3 to the x power equals 243. So 3 to the x power equals 243. And when you take 3 to the 5th power, you get 243, so x equals 5. 23. Got 4 to the x plus 1 power equals 8 to the x minus 3 power. So if I could, both of these I could change to a base 2. So this is going to give me 2 squared x plus 1 equals 2 cubed x minus 3. So since both of the bases are 2, I now know that 2 times x plus 1 has to equal 3 times x minus 3, which means 2x plus 2 equals 3x minus 9. So x equals 11. So natural log base e of 6. So natural log of base e just gives you the 1. So x equals 6. There you go. That, we're going to stop there with 24.